Hello everyone, happy to see you here. Welcome back to my channel, Hi Mathematics. Today we have very interesting equation 5 to the power a plus 5 to the power a equal to 100. We need to solve this equation for a, so if you have your answer, your approach, you can also write it in the comments below and then we will check our answer. So it will be really interesting to see your answer, to hear thoughts about this type of question. So first of all, let's add 5 to the power a plus 5 to the power a. We can easily do this. So 5 to the power a plus 5 to the power a equal to 2 times 5 to the power a equal to 100. And a lot of students might be asking why can we add it, and here's a quick explanation. 5 to the power a, for example, just in your head, for example, 5 to the power 8 equal to, for example, x, and 5 to the power a, this is the same x, so we have x plus x, which is equal to 2x. Okay, so that's why we have 2 times 5 to the power a. Okay, secondly, let's divide both sides by 2. We need to get closer and closer to this a, so let's divide both sides by 2. So let's divide both sides by 2. As a result, we have 5 to the power a equal to 50. This is a classic equation, so the best way to solve this type of equation is to apply log on both sides. So let's do it right now. So let's apply log. So we have log 5 to the power a equal to log 50. So we can easily do this. We apply it on both sides, so without any problems. It's also really great. But this a, in terms of this property, this a will come down right here, because in terms of log, there's like a really interesting property. So when you have log a to the power b right here, this b we can easily write at this place. So we will have b log a. Okay, so I really hope you know this rule. Maybe this is like the most popular log property and the most popular log rule nowadays. Okay, as a result, we have a times log 5 equal to log 50. Okay, right now let's divide both sides by log 5 and then we will have our a without any problem. So let's divide both sides by log 5. As a result, what do we have? We have a equal to log 50 over log 5. And you know, a lot of students may be saying this is a final answer, and you know, I agree with it, this is a final answer, but we can simplify this a little bit, because we have right here log to the log 50 we can write as a product. So we can write log, this 50 can be written as a product, so we can write it as 2 times 25. Okay, let's write it like that, over log 5. And a lot of students may be asking why can we expand it like that, why we can express this 50 as 2 times 25. We have our answer, but in terms of log, there's like really important property. So whenever we have expression like log, so whenever we have a product, so for example log a times b, you can split it in terms of addition. You can write it as log a plus log b. Okay, yeah, when you have multiplication, you can split it in terms of addition. Division, we have subtraction. So you know, whenever we have multiplication, you can split it in terms of addition. So right now, let's do exactly that thing. So we have log 2 plus log 25 over log 5. And you know, right now, a lot of students may be confused because we don't have a common thing. We have all absolutely different bases. We have 25, 5, we have 2, but this 25 right here can be written as 5 square. So let's do it right now. So we have log 2 plus, right here, log 25 can be written as log 5 square over log 5. And right now, according to the same property, these 2 will come down right here. So as a result, we have log 2 plus 2 log 5 and all over log 5. And right now, the final tricky move, we're going to divide our numerator by this log 5, but not the whole numerator, but by parts. Log 2 by log 5 and this expression by log 5. We can easily do that. This is our common denominator. So as a result, we have log 2 over log 5 plus 2 log 5 over log 5, and that's it. Right now, this log 5 we can easily cancel real quick, so we can easily cancel this expression, and I'm going to start with this 2 in the beginning. So we have 2 plus this expression log 2 over log 5, and this is our final answer. But I suggest you to look at this second variation, because this expression can also be written as 2 plus log 2 right here base of 5. Of course, this is up to you. We have both both answers, this one and this one, both answers are correct. But right now I want to show you how can we prove our root. So that's why I choose this expression, I choose this answer, because right now I'm going to prove it. So let's check it, let's prove our root. So let's check our root. We are talking about this one, a equal to this. So we have 2 plus log 2. Right here we have base of 5. Okay, and let's check this root. Where do we have our question? 5 to the a plus 5 to the a equal to 100. So we have our question. So 5 to the a plus 5 to the a equal to 100. So let's check our root real quick. And that's why in a few seconds you will understand why I choose this expression, not this one, but this one. Okay, let's do it. So we have 5 to the power a equal to 2 plus log 2 base of 5 right here, yeah. And we have plus 5 to the power 2 plus log 2 base of 5 equal to 100. And right now, in terms of power rule, we can easily split this power. We can write it as 5 squared, so we can raise 2 to the power, we can raise this power, this 5 to the power 2, and we need to raise 5 to the power this one. So times 5 to the power log 2 base of 5 plus 5 squared times 5 to the power log 5 log 2 base of 5 equal to 100. And right now a lot of students might be confused because we have a really complicated expression. A lot of students might be thinking that, okay, this expression is really complicated, how can we simplify it? But you can easily do this in a few seconds. You just need to know this property right here. You can easily see it, 5 to the power log 5. Yeah, and right here we have 5 to the power log 5. So we have two symmetrical things on both sides. And here's extremely important thing, because this expression, 5 to the power log 5, or doesn't matter, like a to the power log a or 2 to the power log 2, is equal to 1. So we can easily cancel in our head, we can easily cancel these expressions. We have only right here 5 squared 25 times, right here we have only 2, don't forget about it, plus 5 squared 25 times, right here we have only 2, equal to, right here, can we get 100? I guess we can, yeah. So we have 25 times 2, we have 50, plus 50 equal to 100. Yeah, our root is great. Yeah, so in a few seconds I'm thinking that that I thought that we can't get 100 from here, but everything is great. So we have 550 plus 50 equal to 100. So our root is absolutely great. So let's write our final answer to this question. And in the end of the video, in a few seconds, I'm going to show you how can we find a complex root. So our root a equal to 2 plus log 2 base of 5. And maybe someone interested in approximately answer. There are a lot of students, maybe you're interested in approximately answer. So a approximately equal to 2.43. This is up to you. You can easily see this. You can see this like from different perspective. Approximately equal and our full answer. This is our real number root. And right now I want to spend like 1 minute to show you how can we find a complex root. Maybe you are interested in this. So right now let's do this. So right here I have space. So right now I'm going to show you as a second part. So we're going to find a complex. You're going to find a complex root. So I'm going to split this, and right now we're going to spend like 1 minute to find a complex root. First of all, I want to rewrite not this expression from the beginning, not this one, but this one, 5 to the a equal to 50. So right now let's do it. So 5 to the power a equal to 50. And right now, instead of this 5 to the power a, I want to write the next expression. So the first thing, in terms of 5 to the power a, I'm going to write e to the power natural log of 5 to the power a. And this a will come down right here. So we have e to the power a natural log 5. So instead of 5, we're going to write this expression. Instead of 50, in terms of complex numbers, in terms of identities, we can write 50 times e to the power I to k pi. Okay, really great. And k, of course, k is a set from the set of integers. Right now, instead of 50, we're going to plug in this expression. Instead of 5 to the a, we're going to plug in this expression. So let's do it. So we have e to the power a natural log 5 equal to 50 times e to the power I to k pi. How can we simplify it? How can we simplify it? First of all, let's apply log on both sides, natural log. So we have natural log of left side, this one, e to the power a natural log 5 equal to natural log of this expression, 50 times e to the power I to k pi. Really great. But right now, natural log e equal to 1, and this power we can write in front of this natural log in terms of a power rule. This one or this one. I showed this rule before a lot of times, multiple times, so we can easily use this rule. So we have only a natural log 5 on the left side. And on the right side, we can easily apply that rule once more because we have natural log and in parentheses we have a product. So we can easily split it with addition. So we can write it as a sum of two logs. So we have natural log 50 plus natural log of e to the power I 2k pi. And right now, this natural log e equal to 1, and this power we can easily write in front of it the same property as we had right here. So we can easily write this power e I 2k pi, yeah? So we have the same beginning, a natural log 5 equal to natural log 50 plus I 2k pi, because natural log e equal to 1, so I 2k pi. And the final step, let's divide both sides by natural log 5 because we need to find our a. So our final step is to divide both sides. So a equal to natural log 50 plus I 2k pi. And we're going to divide it by natural log 5. Of course, you can express this natural log 50 in a different way. You can express this natural log 50 as natural log 25 plus natural log 2. This is up to you. You can express this as natural log 5 plus natural log 10, but you can easily leave it like that. So this is our complex root. This is our real number root right here. This is our complex root. Of course, write your thoughts, write your response in the comments below. Let's discuss a little bit about this question. What do you think about this? What do you think about this solution? Maybe you have your thoughts, your response, your way. How can you solve it? Because a lot of people, a lot of countries, a lot of discussion. So, right, how can you see question? How can you see this type of question from your perspective, from your angle? It's also really great to exchange information in the comments below and to see to see this information from a different angle. Right now you can see once more, you can see a solution to this question. Yeah, once more I move slowly. You can easily pause this video. To be honest, this is not the hard question, but with the few really interesting tricks, with the interesting tricky moments, you should know about log properties, because there are a lot of log properties. Here we have like more than 2 or 3 properties right here. So I really hope you enjoy logs and you understand my solution. You can also leave your comments and write your thoughts in the comments below. It's also really interesting. So thank you for your time. Take care of yourself and have a great day. See you in the next videos.